I would like to solve this question. Tom and Jerry each choose at random a number in interval 0 and 2. Assume that the probability of any event is proportional to its area, which is basically the uniform probability law. Consider the following event. A is the event that the magnitude of the difference between two numbers is greater than 1/3. B, at least one of the number is greater than 1/3. C, the two numbers are equal. D, Tom's number is greater than 1/3. Find the probability of B, C, and A intersection with D. So I'm going to start with probability of B. First, I'm going to graph the sample space, which is the square of size 2. Each side is 2. It's just because X would be the number that Tom's choose, and Y would be the number that J is going to choose. So this square would be the sample space. So B is the probability that at least one of the numbers is greater than 1/3. So it would be the probability that X is greater than 1/3, or which would be the union, that Y is greater than 1/3. Okay, so let me try to graph it. When X is greater than 1/3, I'm gonna graph this inequality. So first I'm gonna graph the equality 1/3, X equals 1/3, and then I'm gonna choose which region is X greater than 1/3. Is it the left on the line or on the right of the line? So basically I'm gonna choose a point. So if I choose the point 0, 0, 0 in here is not greater than 1/3. So the left of the line is not the region. The right side of the line is the region. So it would be that region, X greater than 1/3. Then I'm gonna graph Y greater than 1/3. So I'm gonna graph Y equals to 1/3. And then with the same idea, if I pick a point, I see that this region above the line would be the region of my interest. Okay, so now that I have the union, I should consider everything except that little square in here. So the probability of that would be 1 minus basically the probability of that small region, which would be the probability that both numbers are smaller than 1/3. Great. So it would be 1 minus, since I have the uniform probability law in here, the probability of that region would be basically the area of this small square. So it would be the area of this square, which is of the size 1/3, over the area of the sample space. Okay, so this would be 1 minus the area of this square is 1/3 times 1/3 over the area of the whole sample space would be the area of that square. So it is 1 minus 1 over 36. So this is 35 over 36. That's probability of B. Now, probability of C. What is the event C? The event C is when the two numbers are equal. When the two numbers are equal, basically, I'm on just that line y equals to x. Okay, so this would be the probability that x is equal to y. And probability of this would be the area of the line, over the area of the sample space. sample space. Okay, let me bring this one just a little on here. Great. So area of the line would be 0. Area of the sample space is 4. So probability of C is 0. Now for finding probability of A intersection with D, basically I erase everything in the sample space to have a nice graph. So what is A? A is the event that the magnitude of the difference between two numbers is greater than 1/3. So probability of A intersection with D. So for A, I have x minus y is greater than 1/3. So where is this event basically? This is x minus y greater than 1/3 and x minus y is less than negative 1/3. Okay, so basically if I want to graph that region, I have two lines to graph. The first one would be, I'm going to graph the equality first. So it would be x minus y equals to 1/3. So I'm going to bring y on the other side. So x minus 1/3 would be y. This is the first line. For the second line, I have x minus y equals to negative 1/3. So I'm going to bring y on the other side, x plus 1/3. Okay, so what do I have? Let me graph it with the nice color. So y equals, oops, what is that? Okay, so I have this line, which is y equals to x, but plus 1/3. And then I have this line, which is y equals to x minus 1/3. Okay, and then for this region that the difference is between is greater than 1/3, if I choose a point in the middle like 0, 0, and then I put 0, 0 in the inequality, I get 0 bigger than 1/3, which is wrong. So the area in the middle is not this region. The area outside is the region. So basically, and here is this region. So this is event A happening here. Now for event D, D is Tom's number is greater than 1/3. So for this one, Tom's is x. So x is greater than 1/3. This is simple. I have 1/3. X equals to 1/3. And since x is greater than 1/3, I pick a point like 2 and 0. Is 2 greater than 1/3? Yes. So the region on the right side of the line would be the region of my interest. So it would be that region. Okay, that's the region D. Now I need to find the intersection. The intersection, as you see in here, would be the shaded area in both overlapping shaded area, which would be basically here and here in this rectangle in here. This is the shaded area. Okay, so I need to find the area in here over the area of the sample space. So area of the overlapping shaded area over the area of the sample space. Okay, area of the sample space, easy, it's 4. So now, how about the area here? This is 1/3. So this side of this triangle would be 2 minus 1/3. 2 minus 1/3. this side, as you see, this part, this little part in here is 1/3. So this part is 2 minus 1/3, 2 minus 1/3 divided by 2, plus the area here, this area here. I need to find this point in here. As you see, let me do a trick. This is y equals to x. So since this blue line is y equals to x. Now x is 1/3. So this intersection point has y equals to 1/3, and then this orange line in here is x plus 1/3. So basically, this side in here, let me choose a good color. So this side in here would be 2 minus 2/3. Okay, because this little part is 1/3, this little part is 1/3. Okay, and how about this side? This is 1/3, this area is 1/3, this little side is 1/3. So this is also 2 minus 2/3. Great. So this is 2 minus 2/3 times 2 minus 2/3 times 1/2. Good. So this is 5/3. This is also 5/3. This is 4/3. This is 4/3. If you do the math, you get 25/18 plus 16/18 divided by 4. So this would be 41/72.